Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, Uni St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, Uni St. Augustine.
My contribution to physics is this. Before my experimental discovery of the massively parallel processing supercomputer that occurred on the 4th of July of 1989, the most extreme scale computational physics codes were only executed on only one supercomputer. After my experimental discovery of the massively parallel processing supercomputer, the most extreme scaled computational physics codes were only executed across millions upon millions of commodity off-the-shelf processors. The precondition to experimentally discovering how to execute the fastest computations across my ensemble of processors and how to do so as one seamless cohesive unit that is a new supercomputer and that is a new internet required that I invent new techniques for sending emails that I visualized as having 5 subject lines and receiving emails that I visualized as having 3 subject lines and sending and receiving those emails to and from 2 to the power 16 or 65,536 16-bit long email addresses, each with no @ sign or .com suffix. In the 1980s, the Department of Energy of the United States government classified the most extreme scale problems in computational physics as grand challenges in supercomputing and as the toughest problems in physics. For me, Philip Emeagwali, to solve the grand challenge problem that was described as extreme scale petroleum reservoir simulation demanded that I be able to extend the frontiers of modern calculus and extend that frontier of knowledge by a distance of 9 partial differential equations of modern calculus and also extend the frontier of modern algebra by a distance of 9 partial difference equations and extend both frontiers of knowledge from the blackboard to the motherboard and extend those frontiers of knowledge across an ensemble of 2 to the power 16 processors that were married together as one cohesive unit and married by 16 times 2 to the power 16 or 1,048,576 bidirectional email wires. Those email wires has a 1-to-1 correspondence to the as many bidirectional edges of the hypercube in the 16th dimensional hyperspace. That is, the lone wolf inventor of the new supercomputer that is a new internet must be a jack of all sciences. The lone wolf inventor of that new internet must be a Renaissance person that is a multidisciplinary trait that can simultaneously extend the boundaries of human knowledge and extend that boundary across computational physics, modern calculus, extreme scale algebra, fastest supercomputer, and a new internet. In summary, we knew the land before parallel processing, and we named that land sequential processing or computing only one thing at a time. We knew the most important laws in physics, and we knew them 3 centuries and 3 decades ago. We knew how to encode those laws of physics as the most advanced expressions in calculus called partial differential equations. And we knew them nearly a century and a half ago. We knew how to discretize those partial differential equations to their algebraic approximations. And we knew them almost a century ago. We knew how to further reduce the systems of equations of algebra and how to reduce them to an equivalent set of floating point arithmetical operations. And we knew them over half a century ago. We had been executing those floating point arithmetical operations since 1946, the year the first digital programmable supercomputer was invented. We knew the land before parallel processing as the land where we computed one thing at a time. In the 1980s, we did not know the land after sequential processing or computing many things at once. What made the news headlines in 1989 was that I did something that was considered physically impossible to do. Namely, I crossed from the land of sequential processing to the land of parallel processing. What made the news headlines was that I experimentally discovered how to solve the most computation-intensive problems of extreme-scale computational physics. On the 4th of July of 1989, I experimentally discovered how to solve those grand challenge problems and how to solve them across 65,536 commodity off-the-shelf processors or across as many identical computers that outline a small internet. The supercomputing community confirmed my discovery, and the June 20, 1990 issue of the Wall Street Journal recorded that I, Philip Emeagwali, had experimentally discovered that we can massively parallel process, and that I discovered it via emails I sent to 16-bit long addresses that each had no @ or .com suffix, and via emails I sent across a small internet. That small internet is a global network of 65,536 commodity processors, or as many identical computers. Finally, I must add that solving the grand challenge problem of computational physics sharpened and deepened our understanding of both the computer and the supercomputer and changed the way we look at both technologies.
Insightful and brilliant lecture.